And it looks like this. All right. So the problem that we had earlier is what we call negative shear, or the element A. Remember the element A that we analyzed with negative shear. So the same thing. I'm going to draw my element here. Okay. So this is X and this is Y. And for the first time, right, both positive shear and negative shear are as bad. There's nothing known as a positive shear is better than negative shear. No, 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 no. Both are as what? As bad. Okay. Right. So why is this called positive shear? So if you look at the shear, and this one over here is on the X plane, right? And because the plane is positive over here, this is a positive plane, right? Because if this is 0, right, that line where it's intersect the plane is what? Positive, and going, so the plane is positive, and the direction of the arrow is Y is also what? Positive, right? The Y over here is also what? Positive. Yes or no? Right? So that is why we call this positive shear. Okay. So if you look at the other arrow over here, the shear, the intersecting plane is Y. So this plane is also positive Y plane, intersecting the Y, right? Positive Y. Does that make sense? Okay. And then the direction of the arrow, this direction, right, is also what? X is also what? Positive. Right? So positive shear. So likewise over here, both are what? Negative plane, negative direction in your X, negative plane, and negative direction in your Y. So negative by negative is what? Positive. So that is why we call this positive. Okay. So if you look on the other element, right? So this plane, okay. So if you look at this arrow that I'm highlighting now, right? So this is shear, right? The plane, the intersecting plane in X is what? So this is X plane, intersecting plane, or the intersecting X plane, or the intersecting plane on the X axis is positive. But this Y direction is what? Negative. So one is positive, one is negative. Positive multiplied by negative is equal to what? Negative. So that is why this is called negative shear. The unique thing is how the structure deform. So I'm going to draw to you how the structure deforms. So it's basically where the two arrows are, right? You got to pinch both of them. Okay. So what do I mean by pinch? When you pinch both of them, this is the deformation pattern. Okay. So this is your deformation pattern. And then when you pinch the other side, right? That is the other deformation pattern. Okay. So now, any questions so far? We're okay? So what we have now, okay, so I'm going to label this now. You guys say, oh, not again. I'm going to label this X. I'm going to label this Y. And I'm going to label this X. And I'm going to label this Y. And then we're going to Mohr circle. So what we see over here, based on this stress state, stress X and stress Y both are equal to what? 0. Right? We did not draw any normal stresses. Then you have shear XY is equal to shear YX, and this is equal to positive. Okay. So likewise for the one below the negative shear, you have stress X and stress Y also equal to 0. the shear xy is equal to shear yx. This is also equal to what? Negative. So the difference comes when we draw Mohr circle. The difference comes when we draw Mohr circle. So we will come here. Oi. So this is my normal stress, right? And then the vertical is our shearing stress. Okay. So the shearing stress element rotate clockwise. Shearing stress element rotate anti-clockwise. So on top, the one at the top is for positive shear. Then the one at the bottom is for negative shear. Okay, it's for negative shear. Right. So we know that both the stress X and stress Y line are on the vertical because the normal stress is equal to 0. Likewise, you have stress X and stress Y on this line because it's equal to what? 0. Now, if you look at point X now, okay, on positive shear, okay, I want you all to focus on the positive shear. If you look at point X now, if you fix at the center, the element will rotate clockwise or anti-clockwise. Anyone? For point X down here that I'm highlighting in yellow now, the element will rotate which direction based on the shear? Positive, clockwise or anti-clockwise?
Clockwise.
Hey,
Will it rotate? Because like,
so based on this arrow over here, clockwise or anti-clockwise?
or anti-clockwise.
Anti-clockwise. Thank you. So anti-clockwise, this is where your point X is, right? And then on the Y, okay, the Y you see now, right? This is going to induce a what? Clockwise rotation. So clockwise rotation is here, right? So this is your Y. Okay, this is your Y, and then you construct your Mohr circle. Okay. And likewise, over here, let's look at negative shear now. Okay. So negative shear, if we look at point X, right, based on this arrow that I'm highlighting now, okay, based on this arrow that I'm highlighting now, can you see the arrow? It's going to generate a clockwise or anti-clockwise rotation. Anyone? Clockwise, right? Okay, so this is your point X. And then on the other point, Y now. Oh, Y is too dark. This arrow will generate a clockwise or anti-clockwise. I hope you guys can answer that, right? It's going to generate a what? Clockwise rotation of the element. Okay, so this is your Mohr circle. Right, so the difference is where your point X and where your point Y on Mohr circle. So important thing to take note, the shear, okay, the position of the shear on Mohr circle, I'll write down here. The position of the shear on Mohr circle is dependent on the rotation of the what? Element. Right? It's dependent on the rotation on the element and not on the magnitude of the shear. So magnitude down here, I mean direction or whether is it positive or what? Negative. So it all dependent on the rotation of the element. Okay, I want you to get this really clear. I did not know that until I'm teaching this course. I did not know this until I was 40 years old, for crying out loud. Okay, I'm so pissed off with my professors now that taught me this. Okay, he did not even bother to explain. Either he did not bother to explain or he did not know. Right. So now I'm going to quickly combine the two, so you guys have a snapshot of what will happen when you combine the two of them. Now remember, this is just 2D Mohr circle. We are going to do 3D Mohr circle later on. Now 3D Mohr circle is still a circle. Does not mean 3D Mohr circle you have a sphere. No. It's still, if it's sphere, I will not be teaching you. I'll tell you that. Okay. Right. So now let's combine everything together. Okay. So let's combine. So now we have an element. Okay. So this is our element. So this is our example. Okay. So we have what we see is an element. So an element, this is X and this is Y. On an element over here, you have this is 30. Okay. And then over here, you have 40. And then you have this, as in you have it in 15. Okay. So what we want to find is we want to find, we're going to find, let's see how much space we have. We have plenty. We're going to find our find maximum shearing stress. We're going to find our principal stress. We're going to find our principal plane. And we are going to construct, the element, or construct and label the principal plane orientation. Okay, I'll tell you what I mean by later on. Okay, so from here we know that stress X is equal to 30 megapascal. Okay, so all of them are megapascal. Okay, and then we know that stress Y is equal to minus 40 megapascal, and the shear XY is equal to shear YX, and it has positive shear plus by 15 megapascal. But like what we saw before, positive shear, negative shear does not really matter at all. Okay, does not really matter at all. So then the first thing we do, standard operation procedure, you label this as X, okay, and then you label this as Y. Okay? You label this as X, label this as Y, and then you draw your Mohr circle. Okay, the scale has to be the same. So this is my Mohr circle. So I'm going to start from minus 50, 40, 30, 20, 10, 0, 10, 20, 30, and 40. Okay, so that's my, and then you do your shear. I think I need a bit more space at the top. Okay. Then the shear. So make sure that the scales are the same, okay? If your scale are not the same, I told you, right? You're not going to get more circle, you're going to get more over, okay? And you don't want that. So this is normal stress. Okay. Then you have shearing stress. And the shear stress can be from VQ over IT or TR over J. Okay, either one. 10, 20,